Today we're going to talk about completing the square. We're going to talk about the basic form that you will need for circle equations, and we're also going to talk about a more general version of completing the square in a later video that we will be using for quadratic functions and quadratic equations. Okay, so the general idea of completing the square is that if we have a quadratic of the form ax squared plus bx plus c, where x is our primary independent variable and a, b, and c are our parameters, we want to convert this into something of the form a times x minus h squared plus k. Now the reason for this is that this form is simpler to work with in a lot of different situations, and it's very helpful in a lot of cases. In fact, when we get to quadratics, this is the form that's much easier to graph. Now we're going to worry about a more basic version of this. We're just going to worry about simplifying x squared plus bx into something of this form. Now when you look at this, you say completing the square. Well, what does that mean? Well, if we look at that x squared term, the reason we call it x squared is because it gives us the area of a square that has side lengths x. So if this top length is x and the side length is x, then this is x squared. Now if we want to form a square, we'll split this part up into two parts. B halves here, B halves here. And if we look at these two rectangles that we've added, we have length x and width b over 2, so this is bx over 2. And likewise, we have a height of b halves and a length of bx over 2. B halves times x is bx over 2. So if we look at this, the area of the shape is exactly that. Now if you notice, this isn't quite a shape. We're missing a square. We're missing this little bit right here. And if we look at the size of this, this is b halves by b halves. So this is going to be b halves squared, or b squared over 4. So what we can do is we can take this expression and we can rewrite it. And what we do is we're going to add this little square that we're missing from our bigger square. And we're also going to subtract it. Now the reason for that is that what we want to do is we want to find an equivalent expression. What that means is it has the same value, but it looks different. It's like translating between different languages for some simple thing. Now, if we notice, what we've done right here is we've added 0. Okay? Now, by adding 0, we haven't changed the expression, but now we have something of the form x squared plus bx plus b squared over 4. That's exactly the area of the square, and if we notice, the square has length x plus b2 and height x plus b2. So these first 1, 2, 3 terms are going to be x plus b over 2 squared, and then we have this little bit left over. And if we notice, we have now converted something of this form, which is a simpler version of this, into something of this form, which we have right here. And so this is why it's called completing the square, is you're taking something that essentially gives you almost the area of the square and adding a little bit in order to get something that looks exactly like a square. And if we look at what we did algebraically, we'll notice that basically what we did is we took the coefficient of the x, divided it by 2, took the coefficient of the x, divided it by 2, squared it, and added it and subtracted it. And that's the general procedure that we have when we're doing completing the square type procedures. So we half the coefficient of the variable, then we square that value, and then we add and subtract it. Okay? So that's the essence of a completing the square type procedure. You have the coefficient of the single variable, not the squared variable, but the linear variable. You take that value and then you square it. So in this case, we would take b and take half of it and then square that. That gives us b squared over 4. And then we add and subtract it to both sides. And then this very last step that we do here is we factor, basically. We take these first 3 terms and we factor them into something of this form.